This is for Year 11 methods. It's numbers 1a, 2a and 3a in 3.2, the remainder theorem and factor theorem. In question 1a, find the remainder when this is divided by x plus 2. The remainder theorem tells me that if I'm dividing by x plus 2, then the remainder is going to equal p of negative 2. So p of negative 2 will be 5 times negative 2 cubed minus 4 times negative 2 squared minus 6 times negative 2 minus 3. Negative 2 cubed is negative 8, so negative 40. Positive 4 times negative 4 is minus 16 plus 12 minus 3. Minus 40 minus 56 plus 12 minus 44 minus 47 is going to be the remainder. In question 2a, find a factor for each of these cubics. Don't divide, just find a factor. Okay, so I'm going to start with p of 1. And if p of 1 gives me a remainder of 0, then I know that that is a factor. So p of 1 will equal 1 plus 1 minus 7 plus 2, and that does not equal 0. I might start and go to p of 2. 2 cubed is 8 plus 4 minus 14 plus 2. 8 and 4 is 12 plus 2 is 14 minus 14 is equal to 0. So I found a factor, and that factor will be x minus 2, because p of 2 gave me a remainder of 0. Okay, in question 3, express each of the following as a product of a quadratic and a linear factor. So in A's case, I've got 2x cubed plus 11x squared plus 17x plus 6. Okay, it's pointless putting p of 1 or p of 2 or p of 3 because there's no way I can get to 0 if all of these are positive coefficients. So I'll start with p of negative 1. So negative 1 will be negative 2, negative 1 squared, so plus 11. That's 17x, so minus 17 plus 6. 6 and 11, 17, but minus 19, that doesn't equal 0, so that's no good. Let's try p of negative 2. Negative 2 cubed is negative 8, so that's minus 16. Negative 2, that's plus 44. Negative 2, that's minus 34, plus 6. If I just add the positives together, that gives me 50. Add the negatives together, that gives me minus 50. Bingo, add them together and I get 0. So p of negative 2 gave me a remainder of 0. Therefore, x plus 2 is a factor. So since x plus 2 is a factor, if I divide x plus 2 into the cubic, then I should be able to find the other factors, and that's what I've got over here. So I've got x goes into 2x cubed, 2x squared times. I'll continue this. Okay, so I've got up to the point where that minus that, 17 minus 14 is 3x plus 6, and x goes into 3x plus 3 times. 3 times x is 3x, 3 times 2 is 6. Subtract the second from the first, remainder of 0, exactly what I wanted. So in answer to the question, what are the product of the quadratic and the linear factors? Then this cubic is equal to x plus 2 and 2x squared plus 7x plus 3, and they are the two factors.